Hello everyone, welcome to Absolute Geography. Here we take your geography understanding from classroom to continents. In this video, we are going to discuss about the factors that affect the climate of India. India's climate is shaped by a dynamic mix of land, sea, winds, and pressure systems. From the vast Pacific to the mighty Himalayas, each play a vital role in creating our climate. India experiences a tropical monsoon type of climate. The term monsoon comes from the Arabic word mawsim, which means season. In fact, we always use this term like when we say मौसम बदल रहा है. It is the rhythmic change in wind direction and rainfall pattern that defines India's season. India's position on globe has a huge impact on its climate. The Tropic of Cancer passes through the middle of India, dividing it into two zones, tropical in south and subtropical in the north. That's why southern India stays warm throughout the year, while the north experiences more seasonal variations. The coastal regions enjoy a maritime climate because of their closeness to the sea, but the inland areas, being far from it, have a continental type of climate. You might remember learning about land and sea breeze, how coastal areas feel cooler during the day and warmer at night. That same idea applies on a much larger scale here. Places close to the sea like Mumbai, Chennai, they enjoy a maritime climate. The sea keeps their temperatures moderate all the year round. But as we move inland, away from the coast, this moderating effect of the sea disappears. Landlocked regions, especially those north of the Tropic of Cancer, they experience a continental type of climate, very hot summers and cold winters. So the further a place is from the sea, the more extreme its climate becomes. The Himalayas act as a massive climatic barrier. When the monsoon winds reach the mountains, they are blocked, due to which they are deflected and shed their moisture in India itself. Else these winds would have gone straight to Central Asia, leaving the northern plains a desert. On the other side, the Himalayas are also stopping the icy Siberian winds from entering India and thus saving us from freezing sub-zero conditions. India's physical features or the physiography play a key role in shaping its climate. The Himalayas in the north act as a climatic barrier, staying snow-covered and cold throughout the year due to their high altitude. The plateaus, being elevated, are cooler than the surrounding plains, which heat up quickly during the summers. The northern plains themselves are low-lying and experience very high temperatures. And then to the west, we have the Aravalli hills running almost parallel to the monsoon winds, so they don't block them. That's why Rajasthan stays dry and has turned into a desert. One of the most important factors influencing India's climate is the monsoon winds. These winds reverse direction with the changing seasons, blowing from the sea to the land in the summer season and from the land to the sea in the winters. This seasonal reversal of wind is what gives India its distinct wet and dry seasons. We'll explore the mechanism of monsoon in detail in the next video. So the monsoon winds bring about India's seasonal changes, but they are not working alone. There are powerful winds high up in the atmosphere that also guide our weather. These are jet streams. High above the earth, in the upper layers of the atmosphere, blow a narrow band of extremely fast winds called jet streams. These winds move at a speed of hundreds of kilometers per hour and play a big role in influencing India's climate. In winter, the subtropical westerly jet flows from west to east across northern India, keeping the region cool and dry. As the summer approaches, this westerly jet shifts northward and a new tropical easterly jet forms over southern India, flowing in the opposite direction, that is, from east to west. This seasonal shift in jet streams helps trigger the onset of monsoon and influence how rainfall is distributed across the country.
Now next is western disturbances. These are low pressure systems that form over the Mediterranean Sea and move eastward guided by the subtropical westerly jet. As they travel across Iran and Pakistan into North India, they bring winter rain and snow to the plains and the Himalayas. This rainfall is small but very crucial. It supports rabi crops like wheat and keep the soil moist during the dry season.
Now, here's something fascinating. India's monsoon is influenced by events happening thousands of kilometers away in the Pacific Ocean. This link is called the Southern Oscillation. It's basically a seesaw pattern of air pressure between the Western Pacific and the Eastern Pacific. Under the normal conditions, the air rises over the warm Western Pacific near Indonesia and moves eastward high up in the atmosphere. Then it cools and sinks over the Eastern Pacific near South America before moving back again along the surface, completing a loop. This movement of air helps global wind and pressure systems, and when this pattern changes, it affects the strength of our monsoon. The oceanic side of Southern Oscillation is the Nino La Nina cycle. So, under normal conditions, the Western Pacific near Indonesia and Australia is warm, while the Eastern Pacific near South America stays cool. This temperature difference keeps the trade winds strong and support a steady monsoon over India. During El Nino, the Central and Eastern Pacific waters warm up. Trade winds weaken and less warm air rises over the Western Pacific, which often leads to a weaker monsoon or even droughts in India. Then in La Nina, the pattern intensifies. The trade winds strengthen, pushing more water towards the Western Pacific, making it even warmer, while the Eastern Pacific becomes cooler. This amplifies the temperature difference across the ocean, strengthens global circulation. For India, this usually means a stronger monsoon, higher rainfall, and sometimes a cooler summer. The Indian Ocean dipole is like Indian Ocean's own version of El Nino and La Nina. Its difference in sea temperature between the western and eastern parts of the Indian Ocean. In positive Indian Ocean dipole, the western Indian Ocean near Africa becomes warmer, while the eastern part near Indonesia turns cooler. This creates low pressure in the west and high pressure in the east, causing winds to blow from west. These winds push warm, moist air towards India, usually bringing stronger monsoon rains. In negative Indian Ocean dipole, the pattern reverses. The eastern Indian Ocean warms up and the western side cools. Now winds move eastward, carrying moisture away from India, often resulting in weaker monsoon rainfall. What's really interesting here is that a positive Indian Ocean dipole can sometimes offset the bad effects of El Nino year. This will help India get normal or even above normal rainfall, even if there is the effect of El Nino year. So, India's climate is shaped by many forces, from its location and landforms to winds, oceans, and global patterns like El Nino and Indian Ocean dipole. All these together decide when the rains will arrive and how strong they'll be. In the next video, we'll explore in detail the climate of India and how the monsoon truly works.